Okay, so this is a non-calculator question. It tells us here that this shape is a regular octagon and these two here are regular pentagons, which means all of the lengths are the same size and all of the angles are the same size. I'm going to use the idea of working with the interior angles of the shape. So I'm going to use the formula of n for the number of sides, minus 2 to give the number of triangles, multiplied by 180. So for the octagon we have 8 sides, minus 2 is 6, multiplied by 180, or 180 multiplied by 6 means that we have a total of 1080 degrees in the octagon. For the pentagon we have 5 minus 2 multiplied by the 180, so this gives us 3 multiplied by 180, which gives us a total of 540 degrees for the pentagon. Because we know that the shapes are regular, this means that the total of the interior angles can be split equally amongst all the angles. So for the octagon we have the 1080 divided by the 8 angles that we have. This gives us that each interior angle is 135 degrees. So each interior angle of the octagon is 135 degrees. We can do the same for the pentagon. So we can do the 540, which is the total, divided by the 5 angles, which gives us that each interior angle of the pentagon is 108 degrees. We can now see that we have an isosceles triangle here, and we can use the idea of the interior angles to work out what this angle of the isosceles triangle is. If the whole angle is 135, and just this part is 108, then we can find this missing angle by doing 135 minus 108, which gives us a missing angle of 27 degrees. So each angle in the isosceles triangle is 27 degrees. We can now use the idea of angles in a triangle to do 27 multiplied by 2 is 54, and to just take this away from 180, which gives us a missing angle of 126 degrees.